Now let's see how you can write equations of a straight line in matrix form, right? So let's look at one linear equation first. This is the general equation of a line, right? Let's see how you can represent this in a matrix form. First, what you must do is convert this into this form. Ax plus by is equal to minus c. Now, you need to separate a and b into one matrix and x and y into another matrix. You need to multiply those matrices, and that must equal to a matrix containing minus c. Now you know that matrix multiplication is rows into columns. And the condition for matrix multiplication is that the columns of matrix 1 must be equal to the number of rows of matrix 2. And now look at this. This is the matrix multiplication that will eventually give you this general equation. Now, rows into columns means that you will multiply A with X, add that to B into Y, and that will give you minus C, right? Now, first we must confirm that the columns of this matrix are equal to the rows of this matrix. Now, A, B. This matrix is a 1 cross 2 matrix, 1 row, 2 columns. And X, Y, this is a 2 cross 1 matrix, 2 rows, 1 column. As you can see, the number of columns of matrix 1 is equal to the number of rows of matrix 2, so they can indeed be multiplied. And now again, you must remember that the remaining two numbers will give you the order of the resultant matrix, and that must be 1 cross 1, right? And that is indeed 1 cross 1 over here. So A into X, AX plus B into Y, BY is equal to minus C. And that is indeed what we have accomplished. Now, let's look at a system of two linear equations. Now, again, the first thing is take the C1 to the right hand side, it will become minus C. Take the C2 to the right hand side, it will become minus C2. So, basically what that means is A1x plus B1y is equal to minus C1, and A2x plus B2y is equal to minus C2. And look at this. This is the 2 cross 2 matrix A1 B1, and that will be multiplied with xy, right? And A2 B2 also multiplied with xy. So let's first confirm if they can indeed be multiplied. So this is a 2 cross 2 matrix. This is a 2 cross 1 matrix. As you can see, the matrices, both matrices, can be multiplied as the columns of matrix 1 is equal to the columns of matrix 2, is equal to the rows of matrix 2, and the resultant must be a matrix of the order 2 cross 1, and that is indeed what we have over here, a 2 cross 1 matrix. Now again, A1 into X, A1 into X plus B1 into Y plus B1 into Y must be equal to minus C1. Okay, that's the first equation we've covered. And similarly, A2 into X, A2 into X plus B2 into Y plus B2 into Y is equal to minus C2. That's indeed the second equation. Now let's look at a system of 3 linear equations. And again, let's do this ourselves. What will this become? This will become A1 x plus b1y is equal to minus c1, a2 x plus b2y is equal to minus c2, a3x plus b3y is equal to minus c3. Now again, the first matrix will have simply two columns, but in this case, three rows. So a1, a2, a3, b1, b2, b3. They will be multiplied with the matrix, with the variable matrix x, y, right? And that will be equal to minus c1 minus c2 minus c3, this matrix. Now, as you can see, this matrix is of the order 3 cross 2. This matrix is of the order 2 cross 1, right? And they can be multiplied indeed, as the columns of matrix 1 is equal to the rows of matrix 2, and the resultant matrix must be a 3 cross 1 matrix, and that is indeed what we have over here, a 3 cross 1 matrix containing the constants. And again, a1 x plus b1 y must be equal to minus c1. We have the first equation, a2 x plus b2 y must be equal to minus c2. That is indeed the second equation, and similarly we have the third equation, a3x plus b3y is equal to minus c3, and that is indeed the third equation. And this is just how you simplify linear equations, by converting them into matrices.